All right, this is the review for Unit 6 test. I recommend you don't try to do it all in one sitting. Do maybe a page at a time or a section at a time. Also, don't just watch me. Maybe watch one and then take a break and try them on your own. The answers are on Canvas as well, so you can do the work and then check your answers. So let's go ahead and get started. If you already saw the first examples in class, you can skip those. So for 6.1, this was identifying functions by equations, graphs, or tables. And so what we're doing is matching equations to their corresponding tables or graphs. So first thing I think is good to do when you get a problem like this is look at the equations and determine what type of equation they are. So when I look at number 1 right here, I see the square root sign, and so I know this is a square root. So I'm just going to make a note there. It's not asking me to do this, but the more information I have, the better. So that's a square root. The next one, number 2, the things I notice right off the bat is that it has a square on it. And so this x is being squared, and whenever we have an x being squared, that means it is a quadratic function. Now, usually you look for something that has an x square, but sometimes it's disguised like this, where the square is on the outside of the parenthesis, but hopefully you remember from Unit 5 that that is still a quadratic function. All right, number 3, I don't see anything interesting going on with the x. There's no squaring, there's no square root, there's no funky exponent, there's no absolute values. The x is just plain and boring, which is my hint that it is a linear equation. The last one, the x is doing something weird. It is up in the exponent. So remember, if the x is in the exponent, it is an exponential equation. So don't get confused. Just because you have an exponent, like in number 2, that square, it is an exponent. That doesn't mean it's exponential. The x has to be in the exponent for it to be exponential. All right, so now we've determined what each of them are. That will help us moving forward. So the next thing I would do is look at the graphs because they are easier than the table. So let's look at the graphs. So when we look at C, hopefully you guys know this by now, but that is a square root graph. It looks kind of similar sometimes to an exponential graph, and I'm going to draw an exponential graph. Looks like this, but you could see how if you were to flip that upside down, it could look like this. And that looks very similar. This looks very similar to this. And so the difference and what you'll notice that will give the giveaway is that the square root function stops. It's going to have a point where it stops, whereas the exponential function, it doesn't stop. It keeps going. So it doesn't stop, it keeps going. And so if you see one that has that kind of gradual curve like that, and you're not sure if it's an exponential or a square root, look at whether or not it stops. If it stops, it's a square root. All right, so we've determined this one is a square root. All right, so since it's a square root, we know we can match it with the equation that's a square root. So number 1 is C. All right, let's look at the next picture. Picture D is a line. So a line is linear. So D is going to be number 3. All right, we have 2 left. We have a quadratic and an exponential left. So that means either A or B. One of them will be quadratic and one will be exponential. So if we remember from our tables, and I'm going to go over to the notes real fast. When we look at our tables for a quadratic, it says the second differences are constant. So that means when we find our differences, the first time they'll be something different. They're not going to be consistent. But then if you find your differences again, they'll all be the same number. And then if we look at exponential, the pattern for exponential is not looking for adding or subtracting differences, but each step multiplies a constant. So it's a multiplying pattern. So if you have a multiplying pattern, that's an exponential. So let's go back to the review and see, do either of these, does A or B look like it has a multiplying pattern? And I'm looking at B, and it definitely looks like it has a multiplying pattern. It looks like we're multiplying by 2 each time. So that's sticking out to me that is a multiplying pattern, which means that one's my exponential one. So B lines up with 4. So by process of elimination, 2 should be A, but before I put it there, let's make sure it has the right pattern. So 0 to 1 is plus 1. 1 to 4 is plus 3. 4 to 9 is plus 5. 9 to 16 is plus 7. So again, not consistent pattern there, but if we find our second differences, from 1 to 3 is plus 2. From 3 to 5 is plus 2. From 5 to 7 is plus 2. So our second differences are consistent, which is what a quadratic pattern should look like. So that confirms it. That is quadratic. And that makes me feel like I got everything right because that last one fit into place. All right, let's do the next one. So again, looking at these, the first one has an x and then a square. So that is going to be my quadratic. The next one, the x is just by itself and boring and plain, so that's going to be my linear. Number 3, the giveaway here is the absolute value signs. Those bars are absolute value signs, which means it's an absolute value equation. Absolute. Okay, and then the last one, I have my x and the exponent again, so that's going to be my exponential. All right. So now looking at the pictures, hopefully you guys know by now that this parabola right here is a quadratic. So hopefully you guys know that by now. This is our quadratic. And then our V-shaped pattern, our V-shaped graph is absolute value. So that one is our absolute value. All right, so let's match those up. So C is quadratic, so that goes with number 1. And D is absolute value, so that goes with number 3. All right, so looking at our tables then, one of them is going to be linear and one of them is going to be exponential. So we already know what an exponential pattern looks like. It's a multiplying pattern. A linear pattern, let's go back to the notes. A linear pattern is where the thing you're adding or subtracting each time is consistent. So you add or subtract the same thing each time. In the example in the notes, we were subtracting 3 each time. So let's look at one of these. Let's find the pattern for B. So, because that looks simpler than those bigger negative numbers. So 5 to 6 is plus 1. 6 to 7 is plus 1. 7 to 8 plus 1. 8 to 9 plus 1. So we're adding the same thing each time. So that should be linear. So that is 2. So that means 4 should be our exponential. So we should be able to find a multiplying pattern. So let's look for one. So how do we get from -2 to -4? Well, we multiply by 2. So even though there's negatives there, it's still multiplying by 2. -4 to -8, we're still multiplying by 2. Okay, so it's still a multiplying pattern. It's still exponential. So A is exponential. All right, number 3. The first one is I see that square root symbol. So I know that one's my square root. The next one, I see x squared, so that's a dead giveaway that is my quadratic. The next one, my x is all by itself, not doing anything special, so it's linear. And the last one, I have the absolute value symbol, so that's my absolute value. All right, so looking at the graphs, I have a parabola again, so that's my quadratic. And then I have one of these slopey ones. So is this going to be an exponential or a square root? Well, it stops right there, so it's going to be a square root. All right, so let's match those up. My quadratic is C, so that's number 2. And then my square root is D, so that's number 1. All right, so between A and B, one of them is going to be linear and one of them is going to be absolute. So we remember the pattern for linear is adding the same thing each time. Let's go remind ourselves what the pattern for absolute is. So the pattern for absolute, it says that the differences are constant and then switch to the opposite constant. Or if you remember what I said is the number stays the same, but your signs are going to switch from like negative to positive or from positive to negative. So the number will be the same in both cases, but one of them, our signs are going to change. So let's go ahead and find our differences on both of these. So -7 to -6, I add 1. To get from -6 to -5, I add 1. From -5 to -4, I add 1. And from -4 to -3, I add 1. So I think that's my linear one. And let's see if B makes sense as absolute value then. From 1 to 0, I subtract 1. And then from 0 to 1, I add 1. 1 to 2, I add 1. 2 to 3, I add 1. So in both cases, my number was 1, and it was consistent both times. But on B, I went from a -1 to +1. So my sign switched. So B is my absolute value. All right, so B is absolute value, so that's 4. And then A was linear. All right, last one of these. It's on the next page. All right, so match each equation to its corresponding graph or table again. Same thing. First one, my clue is that x is in the exponent, so it's exponential. Okay, my next one, my clue is the square root symbol, so it's a square root. My next one, my clue is x squared, so that's a quadratic. And my last one, my clue is that x is boring, so it is linear. All right, let's look at my graphs. So for my graphs, I have a curve, and it stops. It doesn't keep going, so it's square root. If it kept going, I would say it was exponential, but it stops, so it is square root. And then I also have a line, so line is linear. Okay, so square root is C, and my square root was 2. So 2 is C, and then linear was 4, so 4 is D. All right, so A and B, one of them is going to be exponential, and one of them is going to be quadratic. So again, remember, the exponential is a multiplying pattern, and the quadratic is that pattern where the second differences are the same. So looking at these, do any of them look like a multiplying pattern? The fact that A has that really large number 32 makes me want to look at that for a multiplying pattern. And this is kind of a tricky one because 32, how do I get from 32 to 16 by multiplying? I'm actually dividing, and that works too. You could think of it as multiplying or dividing. I'm dividing by 2 each time, which is really the same as multiplying by 1/2. So I'm multiplying by 1/2 each time. So so it is a multiplying pattern, even though it seems like you're taking half of it. You are, but that's still a multiplying pattern. So that's my exponential. And then let's confirm that that B is in fact quadratic. So let's find our differences. 5 to 2 is -3. 2 to 1 is -1. 1 to 2 is +1, and 2 to 5 is +3. And some people might think this is a absolute value because I went from negative to positive, but the number did not stay the same, so it's not absolute value. So let's check our second differences. So -3 to -1, that's adding 2. -1 to +1, I add 2, and 1 to 3, I add 2. So my second differences are consistent, so that is my quadratic. All right, so that is B. All right, let's move on to 6.2. So for 6.2 is where we were describing our transformations. So if you don't have this copy right here, I'm going to add this handout to the Canvas. So it should be on there if you don't have a paper copy of it. If this helps you with the transformations, then it would be a good thing to add to your note card for the test. So I really recommend having it if it helps you. If not, that's totally fine too. Let's go ahead and I'm going to grab the notes for 6.2. We'll clear them. Okay, so here's the regular notes for 6.2. So if you like using these notes, that's fine. You can write that. It's a little bit more concise, writing these pieces right here. But if that's too abstract for you and you get confused about what that means, then you can use this on your note card. All right, so let's do the review. Okay, so first thing is they're telling us what the parent function is. So the parent function in this case, so it says describe the transformation from the parent function f of x equals x squared. So they tell us what the parent function is. Parent function is x squared. So our function is going to be some variation of that. We have to say how it changed. So when I'm looking at it, the things that changed was I subtracted 3 in the parentheses. And the reason there are parentheses is because to subtract 3 before I squared it, I have to have parentheses. And then I also have this negative out here. So I have 2 transformations. Let's write down what they both do. If we look at this example, we can see subtracting something in parentheses looks like this. So it's going to be a shift to the right. Our number's not 6, it's 3. So we'll say shift right 3. All right. The other thing that's going on is that negative sign in front. And so a negative sign in front of our equation, and I'm going to go to the regular notes for this. You can use either one. A negative sign in front of our equation is this right here. See, this is my equation, and it says, look, putting a negative sign in front, what that does is reflect it over the x-axis. So back to the review, we're going to write reflect over x-axis. And on the test, you need to include both the fact that it's reflecting and which way it's reflecting. You can't just say reflect or flipped. You can say flip if you want, but you can't just say flip. You have to say flip over the x-axis, or if you'd like to, you can say it's flipping vertically because it's going, the flip is happening up and down, which is vertically. You could also say up and down, but you need to tell me which direction it's flipping. Same with the shift. You have to use the word shift, and then you have to tell me which way it's shifting and then how much. So I need all of that information. All right. Next one. So our equation is 0.5 x squared plus 4. So the things that are different are this number in front and then this plus 4 at the end. And so let's see. So having a number at the end, that looks like these examples, right? We add a number at the end. So what that does is it shifts it up. So we'll write shift up 4. The number in front, that number is less than 1. So a number less than 1 is going to shrink. Shrink by 0.5. All right, and I'm going to show you again on this example page. So shrinks happen when we have a number that's less than 1, like a fraction or a decimal. Stretches happen when we have a number bigger than 1. So anytime you have a number in front of your equation, in this case, ours looked closest to that. If you don't like the word shrink, you are welcome to also use the word compress. But you need to either use the word shrink or compress or the word stretch. I need one of those descriptions. All right, last one on this row. So the things that are different about it, I see, let's see, I'm adding this 1. I also have a negative, and I also have a 2 in front. So that negative 2, I know we think of that as one thing, but it's really affecting the equation in 2 different ways. The negative affects it, and the 2 affects it. So on the test, you have to make sure you're getting all of the different transformations, which I think you guys are pretty good at. Sometimes you tried to look for transformations that weren't there. But make sure you're getting all the different transformations. The things you can check is there a shift? Is there a reflection? And is there a stretch or shrink? All right. So let's just look at these from left to right. So this negative in front, a negative in front, if we remember, it reflects over x-axis. And I'm going to show you on the chart where that is. Right here, a negative in front of your equation looks like that. So the negative in front of the equation, and it reflects over the x-axis. All right, the next thing is the 2, and we talked about that just a minute ago. A 2 is going to stretch because 2 is bigger than 1, so it's going to stretch by 2. And the last thing is adding 1 inside those parentheses. So that's going to be a shift because we're adding or subtracting something. And then it's going to shift to the left 1. Shift to the left 1. And you guys can refer to the notes if you need to. I'm not going to keep going back and forth each time. Well, I'll go one more time. So it's an adding. So when you add in the parentheses, that shifts left. All right, let's go to the transformations of our parent function when our parent function is absolute value of x. So all of these are transformations of absolute value of x. That's our basic function that we're making changes on. So the first one, the changes I see, I'm looking for what's different compared to absolute value of x. Well, this 2 is different, and this -6 is different. The 2 is going to stretch by 2, and the -6 is going to shift down 6. We don't write -6 because the negative is what tells us it's down. So we've already described that it's going down. So the 6 tells us how much. We don't need to say negative. The reason it's down, the reason it's up and down instead of left and right is because it's outside the absolute value, not inside the absolute value. All right, next one. F of x equals negative, and then x minus 5. All right, so now we have a negative in front. A negative in front does what? It reflects over the x-axis. And then the -5 this time, we're subtracting inside the absolute value. So that's going to be a shift left or right, and it's going to shift to the right. 5. All right, last one. We have a lot going on this one. Let's see. We have this fraction in front. We have -7 inside and +2. So we have 3 different things to describe. So first, the fraction, it's going to shrink because it's smaller than 1. So it will shrink by 2/3. The -7 is going to shift. It's going to shift right 7, and the +2 is going to shift up 2. All right, now we are working on transformations with the parent function being square root of x. So we're starting with square root of x. We want to see what's different compared to square root of x. So the first one has a negative sign, and it also has a fraction out front. So again, those are 2 different things. So the negative sign in front, remember that reflects it. And which way does it reflect it? It reflects over the x-axis. And then the 3/4 is less than 1, so that will be a shrink. Shrink by 3/4. All right, next one. The things that are different, I have a negative sign inside my square root now, and I have a +9. So I'm going to go back to the chart to show you something. So that negative sign, the negative inside my square root, looks like this. So now this is going to be a reflects over the y-axis. So that's the difference between reflecting over the y-axis versus reflecting over the x-axis. One is the negative on the inside versus the negative on the outside. So this time the negative's on the inside, so it's going to be reflecting over the y-axis. Okay, reflect over y-axis. So last time the negative was in front, so it was over the x-axis. Now the negative's inside, so it's over the y-axis. All right, and then our +9, that's inside as well, so that's going to move it left or right, and it is going to shift it left by 9. All right, last problem on this row. So the things that are different, let's see, we have a 4 in front, we have a -1 under our square root, and we have a -1 outside our square root. So the 4 in front is going to stretch by 4. So again, it's bigger than 1, so it's going to stretch. The -1 inside the square root is going to shift left or right, and it's going to shift to the right by 1. And then the -3 outside is going to go up and down, so it's going to shift down 3. All right, last one. These are the ones where our parent function is 2 to the x. So again, the basic function is 2 to the x. So we're looking for what's different from 2 to the x. So looking at the first one, this negative sign is different and this plus 8 is different. Some people, they see this 2 right here and they think it's different. They think it's maybe a stretch that it's being multiplied by 2. But I already have a 2 in my equation, so that 2 is not a change. That's part of the original parent function, so it's not a change. So we don't consider the 2. It's part of what's already there, so it's not a transformation. All right, so the negative, remember the negative's in front, so it's going to reflect over the x-axis. And then the plus 8 is up in the exponent. So I'm going to go to the example page again. So it's up in the exponent. So if you can see, that kind of looks like right here. We have something up in the exponent, so that's going to be a shift left. Okay, so shift left 8. All right, next one, the things that are different. I have this 1/5 in front. So this 1/5 is different than the 2. The 2's part of the equation, but the 1/5 is something in front that's being multiplied. I have a negative in that exponent space and a plus 6. So I have 3 things going on here. So first, that 1/5, it's a fraction, so it's going to shrink by 1/5. That negative 1/5 in the exponent, because it's in the exponent, it's going to reflect. Remember, negatives always reflect. Subtracting something shifts, but making the x negative reflects. And it's going to reflect over the y-axis. And I'll go show you that one too. So that one is right here. So right there, because the negative's in the exponent space, it's reflecting over the y-axis. All right, and then the last thing, the plus 6, hopefully you guys know that by now, that is a shift up 6. All right, last one, things that are different. I have a 2 in front. That's not the 2 that's part of the equation, that's another 2 that's multiplied in front. And then I have -4 in my exponent space and -7 at the end. All right, so that -2 that is in front, that's not part of my original 2 to the x, that -2 is going to be a stretch by 2. -4 in the exponent space, that's kind of like my 8 on this first example. Because it's in the exponent space, it's going to shift it left or right. It's negative, so it's going to shift it right. So shift right 4. The -7 is not in the exponent space, so it's going to shift it up or down. It's going to shift it down. Shift down 7. And that is the end of that. So on to 6.3. All right, so on to the third page, and this is the review for the material from lesson 6.3, which is combining functions by adding, subtracting, and multiplying. So we have 4 examples of each. So let's go ahead and get started. So first problem, we are going to find f of x plus g of x. So go ahead and write f of x, which is 3x minus 4, and then we're adding, so put a plus symbol, and then we're going to find g of x, which is x squared plus 7x. All right, so once you've written both of them and you're adding it, the only thing left to do is combine like terms. So I always like to start by looking for my x's with the highest power first, which is my x squared terms, and I just have the one of those, and it's a positive, so I'm gonna go ahead and write that down, x squared. Next, there's x's, so let's look for x's. I have plus 7, and I also have plus 3 there at the beginning. So when I put those together, 3 plus 7 is plus 10x. And the last thing I have left is just my -4. And that is it. So adding is very simple. You just write the 2 functions and then you add them and combine like terms. All right, next example, example B, we're going to add f of x and h of x. So f of x again is 3x minus 4, h of x, so we're adding, h of x is x plus 6. All right, combine your like terms. We don't have any x squares, but we do have x's. We have 3 of them here and plus 1 of them there. So altogether that is 4x. And then we can look at our constants. That's our numbers without variables. And we have -4 plus 6. So altogether that's -2. All right, next one, g of x plus k of x. So g of x is x squared plus 7x. And we're adding k of x, which is x squared minus 1. Okay, like terms, we have x squared there and x squared there. So we have one of them and then we have another of them. So altogether we have 2x squared. And then as far as x's, we have 7 of them. And then constants, what we have left over is just the 1. All right, last one, m of x plus n of x. So m of x is 2x squared minus 5. And then we're adding n of x, which is x squared minus 3x plus 4. So again, we'll start by looking for x squares. We have 1 there, and we have 2 there and 1 there. So altogether, that ends up being 3x squared. And then let's look for any x's that we have. We have those there, which is -3 of them, so minus 3x. And then look for our constants. We have 2 to group together. We have those ones and those ones, so -5 plus 4 ends up being -1. All right, adding is pretty simple. I think most of you did a really good job with adding, so just make sure you keep your work neat and make sure you write down the right equations and you should be fine. All right, subtracting. The most important thing to remember when subtracting is to remember to distribute your negative. So the best way to remember to distribute your negative is to use parentheses on the thing that's being subtracted. So we are subtracting f of x, subtract g of x. I guess I don't need to write that, it's already there. Let's write what f of x is. F of x is 3x minus 4, and we're subtracting. And I'm going to put parentheses because we want to subtract all of it. And g of x is x squared plus 7x. So we want to subtract it all, so that means this negative here needs to distribute to both the x squared term and the 7x term. Both of them need to become negative. We need to take the opposite of both of them. So rewrite everything we have. We have 3x minus 4, and then subtract x squared, and also subtract 7x. All right, let's look for our terms. Start with our x squares. We have a negative x squared, so let's write that first. And then we can look for our x's. We have plus 3 of them there and -7 of them there. So altogether, that is -4x squared. Or sorry, just -4x, excuse me. And then our constants is -4. So when you're doing this, you should have one extra step for your subtractions because you have to do that distributing the negative. That should take you a step. And again, I really highly recommend you use parentheses to keep it straight that you're distributing that negative throughout all of your pieces. All right, next problem. F of x, which is 3x minus 4, subtract h of x, which is x plus 6. All right, so again, we want to make both of those pieces negative. So let's again rewrite what f of x is, 3x minus 4, and we're going to make the x negative and the 6 negative. All right, combine like terms, which are our x's. So 3x minus x is 2x. And then -4 and minus 6 is going to be -10. All right, next one, g of x minus k of x. So g of x is x squared plus 7x, and we're subtracting k of x, which is x squared minus 1. All right, so this negative that gets distributed, it's going to make this x squared negative, but it's going to make the 1 positive because it switched to the sign. The negative times the negative 1 becomes positive. Another way to think about it is that negative outside the parentheses switches the sign of everything in the parentheses. We'll just rewrite the first term. The g of x stays the same. We don't change it. All right, so g of x stayed the same. K of x, everything became negative of what it was, the opposite of what it was. All right, now we can combine our like terms. We have an x squared here and a negative x squared there. When you have something and then you have the opposite of something, that ends up being 0. So those actually, x squared subtract x squared ends up being 0. Sometimes we like to say those cancel out. They don't really, what they do is they add to become 0. So we don't have to write any x squares because we have none left. As far as x's, we still have 7x. And then we still have plus 1 for our constant. All right, last one, m of x. And m is 2x squared minus 5. And then we're subtracting n. And n is x squared minus 3x plus 4. I think, let me make sure. Yep. All right. So again, remember that negative is going to apply to everything in the parentheses. It's going to flip everything opposite. So the first term will end up being negative x squared. The 3x will become positive 3x. And the 4 will become negative 4. All right, our first term, our first function mx will stay the same. So 2x squared minus 5. Now we have minus x squared plus 3x and minus 4. So as you can see, everything that was in the parentheses, the signs got switched. Now we can combine our like terms. We have 2x squares and a minus x squared. So you have 2 of something and then you take 1 away, you're left with just 1. So you're left with 1x squared. And then for our x's, we have plus 3x, just that's the only term that has x's in it. So plus 3x, and then our constants, we have negative 5 and negative 4, so that will become negative 9. All right, and we are done with subtraction. Let's move on to multiplication. All right, so f of x times g of x. So again, f of x is 3x minus 4, and we're multiplying, so we're going to put both terms in parentheses, and g of x is x squared plus 7x. All right, I'm going to do this one foiling, but I'm going to do the next one box, so you can pick which method you like better. So for the FOIL, I'm going to first multiply my first term to my first term, and that gives me 3x times x squared. So I multiply my constants. 3 times 1 is 3. My x's, I have 1x times x squared, which is 2x's. So altogether I have 3x's. Then I'm going to multiply my first term to my, so my outside terms, my 3 times my 7x. That becomes 21, because 3 times 7 is 21, and then x times x is x squared. All right, now let's work on the negative 4. Negative 4 times x squared becomes negative 4x squared. And then negative 4 times 7x. So negative 4 times 7 is negative 28, and then you have an x, so it's negative 28x. We do have some like terms. We have this and this, those are like. So let's combine them let's start writing out what we have and we'll combine when we get there. So our highest power is x cubed, so we'll write that one first. So 3x cubed. So that is this term right here. And then we have some x squared terms. We have 2 of them. We have 21x squared, subtract 4x squared. So altogether that ends up being plus 17x squared. And then last thing we have is the minus 28x. So those are all of our terms and we're done. All right, let's do the next one using the box method. So this is f of x times h of x, and they both have 2 terms. So we'll make a 2 by 2 box. F of x, we'll put it on the top. It doesn't matter which one goes on the top and which one goes on the side, as long as you have enough spaces in your grid for it. All right, so f of x is 3x minus 4, and h of x is x plus 6. All right, so in each box we multiply the things that go to that box. So this box will be this and this. So that is x times 3x. So the constant is 3, x times x is x squared. The lower left box is 6 times 3x, so that will be 18x. Upper right box, negative 4x. Lower right box, negative 24. When you do the box, it's not always the case, but often you'll find your like terms are going to be kind of diagonally from each other, and that's the case here. So let's start by collecting our terms. Our highest power, that means the x of the highest exponent, is 3x squared. So we'll write that one, 3x squared. And then, like I said, these two here are like terms. So 18x minus 4x is plus 14x. And then subtract 24. All right, so we are done there. All right, I'll do this one FOIL, and then I'll do the last one box again. So g of x times k of x. So g of x is x squared plus 7x, and then we're going to multiply, times k of x, which is, what is k of x again? X squared minus 1. All right. So x, the first terms, x squared times x squared is x to the 4th. And then, the outside terms, x squared times negative 1 is negative x squared. And then we do 7x times x squared, so that will be positive 7, and then x times x squared is x cubed. And then our last terms is 7x times negative 1 will be negative 7x. So we have all of our terms, and let's just start listing them in order from highest exponent to least highest exponent. So highest exponent is x to the 4th, and then we have plus 7x cubed, and then minus x squared minus 7x. And there's nothing to combine. All of them have different powers, so none of them are like terms. All right, last one, m times n. So this one, m has 2 terms and n has 3. So I'm going to do a 2 by 3. And n is the one that has 2, so it's going to go on the side, 2x squared minus 5. And n has 3 terms, so it will go on the top, x squared minus 3x plus 4. All right, so my top left box, I have 2x squared times x squared. So that gives me 2x to the 4th. Next box over, 2x squared times negative 3x. So multiply my constants, I have negative 6. And then I have x squared times x is x cubed. Last box on the top row, 4 times 2 is 8. And then x squared. All right, bottom row, negative 5 times x squared is negative 5x squared. Negative 5 times negative 3x is positive 15x. And then last box, negative 5 times 4 is negative 20. All right, so again, let's start listing these from highest exponent. Our highest exponent is this top left box here. So 2x to the 4th. Then I next have to find my x cubed terms. So for my x cubed terms, I just have one of them, and it is negative 6x cubed. I'm going to check these off as I get them. All right, then my next highest exponent will be x squared, and I have 2 of them. I have this one on the right and then this one on the bottom. So I have positive 8 and negative 5. So altogether that's positive 3x squared. And then last but not least, negative 20. All right, so that is the last one. All right. All right, so let's go on to the last page. This is the review for 6.4, where we are talking about composite functions. So the review looks a little different than the homework, but it is essentially the same thing what we're doing. We just added T-charts to organize what we're working on. So just to review, I'm going to pull up the notes real fast. So for composite functions, we have 2 different ways we've talked about doing it. We can evaluate them at a specific value, or we can create an expression that can be used for any value. So going back to the review, we're going to try these problems both ways. So starting with the first one, it says complete the chart for a of b of x. And then on the chart here, it shows us a of b of x written with the other notation. All right, so we are going to, so a is negative x plus 6, and b equals 5x squared minus x. So if we want to evaluate at a specific value, for example, negative 3, so if we wanted to find a of b of negative 3, we would first, according to our notes, let's look at our notes. Our step 1 is to plug the x value in for the innermost function and solve. So plugging it into b first, which is our inner function, we plug 3 into b and we get 5, negative 3 squared minus negative 3. And so that will be 5 times 9, because negative 3 squared is negative, times a negative is a positive 9. And then minus, or subtract negative 3, it becomes plus 3. All right, 5 times 9 is 45, plus 3 equals 48. So that's our first step. We plugged our value into our inner equation, b, and we solved and we got 48. So looking at the notes again, our second step is to take our answer and plug it in for the x of the outer equation and solve. So our outer equation is a, so we're going to plug in 48 into our a equation. So we're going to plug it into this equation, and we will get negative 48. We're plugging in for the x of this a equation plus 6. So we're going to get negative 48 plus 6 equals negative 42. So then we're finished, and that is the value of a of b of negative 3, and we can go ahead and plug that value in right there in our chart. So we could go through and do this for every single value. We could do it for negative 2, negative 1, 0, and 1. And that could take a little bit of time, but we could do that for every single one. Instead, though, we are going to do what the second part of the notes is, which is to find an expression that can be used for any value. Then once we have that expression, we can use it for the rest of the values. So to do that, it says first we're going to plug the entire innermost function into the x values of the outer equation. So we have to plug, and let's do this in a different color here. So we're going to plug all of b, which is our inner function. We're going to plug all of that into the x value right there of our outer function a. So a of b of x is going to equal negative, we're going to write what a is. A is negative x plus 6, but instead of x, we're going to write all of what b is, 5x squared minus x. And we finish out what a is. So as you can see, this and this is part of a, and then what we plugged in where the x was is what b was. All right. So step 2 on our notes says to simplify where possible. So we're going to go ahead and simplify. So when we simplify, we get negative 5x squared, and then the negative distributing to the negative x becomes positive x, and then plus 6. So here is our expression we can use for any value. So now that we have this expression, we can plug in all of our x values, the rest of them that we haven't done yet. Negative 2, negative 1, 0, and 1. We can plug all of those into our two x's and solve and get our values. So that's why I have the calculator here. I'm going to use that to write my equation and just change my value. So I have negative 5, and then in parentheses. So let's go ahead and write. I'm going to write here what I'm going to put in, though. So I'm going to do it for negative 2 first. So negative 5, and then I'm going to plug in negative 2 squared plus negative 2 plus 6. So this is plugging in that next value of negative 2. So let's do that on the calculator. And then plus negative 2, and then plus 6. So go ahead and enter, and we get negative 16. All right. So the nice thing about the calculator is that we can then just reuse our work. So if we hit up, and then we hit up again, it will highlight our equation. We hit enter, and it re-enters it so we can edit it. So we can scroll over, and where we had negative 2, if we go all the way over there, I'm going to highlight on top of the negative sign and delete it so there's no more negative, and then right on top of the 2, I'm not going to delete the 2 because I want to use that same space. Right on top of the 2, oh, you know what, I want -1, so I want the negative. So I have to hit second insert so I can put a negative back in. Then on top of the 2, you know what, I'm really messing it up. Okay, there we go. On top, I have the negative back and then a 1. All right, so back over to the -2, change that to 1. So it's usually much simpler, but trial and error, you'll get there. So instead of -2, now I have my equation with -1. And you don't have to scroll to the end of the equation to hit enter. You can, but you can hit enter wherever you are once you have the equation the way you want it. So I hit enter and I get 0. So write 0 in on my chart. Now let's go back to my calculator, hit up twice, hit enter. So now it re-enters my equation. I can edit again. So now I want to get rid of my negative sign. So I'm going to go over, hit delete on the negative, and then right on top of the 1, I'm going to put 0 because that's the next value I want to put in. Go over to this one, delete the negative, and then I'm going to change the 1 to a 0 and hit enter. So when we evaluate the equation at 0, we get a 6. And then last time, we'll go up into the equation and then change those zeros to 1 and hit enter again, and we get 2. So as you can see, by finding the this equation here, this expression where we put together the composite function, the two functions together, it's much easier to then fill out the chart instead of having to do all of this work each time. So having to do all of that work each time would get time consuming. If you're more comfortable doing it that way, you're more than welcome to do it that way on the test or on the review. I'm going to show you doing it the composite function way though. So go ahead and try the next one on your own, pause, but I'm going to just keep going. So let's scroll over and let's do 6.4-2. All right, so now they want us to find the composite C of D of X. So we have C and we want C of D. All right, so we are going to do, so C equals 4x minus 10 and D equals 2x squared plus 5. So again, remember, we're going to take all of this and we're going to plug it in for our x and c. So we're going to have 4, and then instead of x, we'll put the 2x squared plus 5, and then minus 10. And then our next step is to simplify. To do that, we're going to have to distribute this -4. So then we have 4x squared plus 20 minus 10. We can combine the like terms at the end, those constants. So we have 4x squared plus 10. Oh, that should be 8x squared. All right. 4 times 2 is 8. All right, 8x squared plus 10. So there we have our equation. Now let's put that in our calculator. And let's go ahead and put it in for our first value. Our first value we're going to work with is -1. So we're going to put it in the calculator with -1. So 8, parenthesis, -1 squared plus 10. And we get 18. All right, now let's go back. So remember, we just hit the up arrow to go back, hit enter, and then we can go back and edit it. We're going to delete the negative sign, and then right on top of the 1, don't delete the 1, but on top of the 1, put the next value we want, which is 0. And we get 10. Up again, hit enter, and we can go over to the 0 and change it to a 1. We get 18. Up, enter, scroll to the 1. We're changing it now. The value we want is the 2. Enter. Oops, see what happened? I did something there. I got rid of my parentheses somehow, and so my equation doesn't look right. So I'm going to scroll up till I get the equation I want, hit enter. Now let's go back and edit it. I must have deleted something. All right, there we go, 42. So just make sure your equation looks right when you hit enter. Okay, and then the last number we need to put in is 3. The last number. Okay, so change that to a 3. Enter. All right, 82. All right, and so there we've done all of the different numbers, and we filled out our chart. So by finding the composite function right here first, it's much easier to find all of the values instead of doing each one individually and having to plug it in first to the inside function, solving, and then plugging it into the outside value. It allows you to do it all in one step. All right, let's scroll to the third one. And this time they want us to find f of g of x. So I got to figure out what f and g are. So going back up, f is 2x plus 1. And g equals x squared minus 3x. Okay, let me just make sure I wrote those right. All right, sorry for all the scrolling back and forth. Okay, so we want f of g of x. So again, that means we are putting g into the x of f. All right, so we're going to have f of g of x is going to equal 2, and then instead of the x, we'll write x squared minus 3x. We'll put all of what g is, and then plus 1. All right, same thing, we're going to distribute. This 2 will multiply to both things, so we'll have 2x squared minus 6x plus 1. So that is our equation that we can put in our calculator. Let's go ahead and see what our first value is, -3 though, so I'm just going to write what I'm going to plug in. So I'll put 2 -3 squared minus 6 times -3 plus 1. And it's always good to have your parentheses. As you can see, when I deleted my parenthesis on that last one, it caused problems, so make sure you keep your parentheses. All right, 2 parenthesis -3 parenthesis squared minus 6 parenthesis -3 plus 1. All right, does it look the same? It does. All right, and 37. Okay. All right, and then our next value that we're going to plug in is -1. So we're going to go up to our equation, edit it. We want to keep the negatives. I'll change this one first. But we'll change the 3's to -1's. Enter, and we get 9. All right. So once you get the equation in once, see how it's so easy to just go in and edit it. All right, so this time we want to delete the negative, and our next value we're putting in is 1, so we'll just leave it as 1. If you ever delete more than you need, like I did that one time, you push the second button, that's that blue button, and then you push the same button as delete, it's insert once you've pushed second, and then when you click it, it's insert, and that will let you add something without going on top of what's already there. And I think I need to do that because somehow I deleted my square. Oh, I deleted a lot of things. I don't know what I did. I touched them when I was showing you. Okay, so we want 2, and then we want parenthesis right here. I need to insert a square, and it will keep inserting until you use your arrow. So I'm still inserting -6. All right, and then I can use my arrow and it stops inserting now. Okay, I'm going to arrow over, make sure it looks right. So my equation is 2x squared minus 6x plus 1, and I'm plugging 1 in for x, so that's correct. Okay, and I get -3. All right. All right. So if you ever get messed up, the other thing you can do is you can use the up arrow and go back to like one of your equations that was good and just try again. But this one's good right now, so I'll just stick with it. Okay, so instead of 1, now the next value we're putting in is 3. So change those to a 3. And the value we get is 1. And then the last value we need to try is a 5. So change those 3's to a 5. So definitely practice doing this on a calculator because watching me is one thing, doing it yourself, it's good to practice it. All right, 21. So that one's done. All right. For the last one, we are finding h of k of x. So again, let me scroll up and see. H, ooh, H is something big. X squared minus 7x plus 6. H equals x squared minus 7x plus 6. And K equals 2x squared. All right, so again, it's H of K of X. So that means we're putting K into H. So right here, we're putting K into H, you can see. Again, if you ever just have this notation and that confuses you, try to say it out loud. And remember that little dot means of. So that's H of K of X. And since it's H of K, that means you're putting K into H. And again, remember, you read left to right, but the way you plug things in is you plug things in from right to left. Okay? So you plug it in starting, with the X and then to the K, and then the K goes into the H. You can always rewrite it though too. When you rewrite it, the letters are in the same order. You see the H is always first, and then the K, and then the X, same order. But if you change it to the parenthesis notation, sometimes it's easier to see what's inside. And because in the parentheses, it's easy to see that the K is inside the H. All right, so we want to put K inside H. So that means that wherever we have an X, we need to put K there. So we're going to put K there, and we're going to put K there. There's two different places we have to plug it in. So we're going to go 2x squared, and then we're going to square that, minus 7, and then we'll put K again there, 2x squared, and then plus 6. So that one is a little trickier. So again, wherever there was an X, we replaced it with K, and K is 2x squared. All right, so 2x squared squared. That means what that means is 2x squared times 2x squared. And so that, hopefully you guys are getting good at that. You multiply the constant, so 2 times 2 is 4. And then x squared times x squared is x to the 4th. So this whole piece right here is the same as that, which is the same as that. So 4x to the 4th. All right. And then negative 7 times 2x squared. So let's distribute. Oop, that is an eraser. All right. So let's multiply or distribute that negative 7. So negative 7 times 2 is negative 14x squared. And then we still have plus 6. So our overall equation is 4x to the 4th minus 14x plus 6. All right. So the first value we're going to plug in is negative 2. So I'm going to write down that one so I know how to put it in my calculator. 4, and then we'll put negative 2 to the 4th power minus 14, negative 2 squared plus 6. So this is what I'm going to put in my calculator. All right, so 4, and then in parentheses, negative 2, parentheses. Now I need to go to the 4th power, so I can't just use the square button. And where is it on this calculator? I don't know on this calculator. Usually there's one that has an X and then like a little number up above. If you're at home watching this and you see it and you're like, why can't she see it? All right, we might have to do this one in our head, which is fine, because I cannot find. Let me try hitting math. I think it's easier on your calculator. This is a different. See, there's the cube one. All right, I give up with this calculator. If you see it and you're thinking, why can't she see it? I'm sorry. We're just going to have to do this one by hand. That's okay. All right. So negative 2 to the 4th power means negative 2 times negative 2 times negative 2 times negative 2. So I'm going to do that off to the side over here. Negative 2 times negative 2 times negative 2 times negative 2. Which is going to negative. Okay. So the negatives will cancel because I have negative times negative times negative times negative, so it's going to be positive 16. So 16 times 4, which is 64. No, yes. Let's double check that. It's getting late. 16 times 4. Yep, 64. All right. And then minus 14 times negative 2 squared. Negative 2 squared is 4. So 14 times 4 is 56. So let's just write 56 there instead. And you know what? We're not going to give you one this hard on the test. So if you're at this point and you just want to be done watching, you can be done. It will not be this hard. All right, 64 minus 56 plus 6. So 64 minus 56 plus 6. And we get 14. All right. I'm going to erase my work each time so we have room. That one's probably the hardest one. All right, negative 1. So negative 1 to anything power is just 1. And it's, it's negative. So negative 1 times negative 1 is positive 1 times negative 1 times negative 1 is positive 1. So it's going to be, I keep keeping the eraser. Okay. So it will be 4 times 1 minus 14 times 1 plus 6. So that's 4 minus 14 plus 6. So that's negative 10 plus 6 is negative 4. All right. 0. 0 should be easy. 0 is 0 to the 4th is just 0. So 4 times 0 is 0. Negative 14 times 0 is 0. So it'll just be 6. And then we already figured out what 1 was, or what negative 1 was. Oh, that should be a positive 1. Oops. Should be a positive 1 right there. We already figured out what negative 1 is, and 1 is going to be the same. So it's going to be negative 4, and 2 will also be the same as negative 2, 14. That's not always the case, but in this case it is. All right. I'm going to look at your calculators when I get to school and see if it is easy to find the button to raise it to any power. I think it is because I think I've done it. All right, so that is the end of the review. Hopefully it went well, and good luck on the test. We'll see you in class.